Now let's start with the module Introduction to C++. As we know, computers cannot perform anything on its own. We have to give him the step-by-step procedure to perform a particular task. Now to give these particular specifications, a step-by-step procedure, we need a language which will act as an interface between the user and the computer. These language interfaces are basically called as the programming languages. Programming languages can be categorized into three major categories. These are high-level programming languages, low-level programming languages, and object-oriented programming languages. High-level programming languages are very close, where the syntax is very close to the natural language, and for the user it is very easy to write the programs in high-level programming languages. Low-level programming language syntax is very close to the machine architecture and mostly in zeros and ones. So it is that way difficult for the programmer to write the programs in low-level programming languages. In object-oriented programming languages, the programming is based on the real-world problems or real-world entities where the objects are defined and their relationship with each other are defined. C++ is an object-oriented programming language. It is considered as a superset of C, where all the programs of C can be compiled using C++ compiler. So let's start and see the C++ programming language. C is a procedural language which is very powerful and mainly used in developing of system software like operating system kernel, compilers, editors, etc. and is also used for developing application software. Even though C is an excellent programming language, it cannot model real world problems. In C language, once a program exceeds from 25,000 to 100,000 lines of code, it becomes so complex that it is difficult to take hold of as a whole. The solution for this type of problem has led development of C++ language, in which the programmer has the ability to understand and manage larger, more complex programs. The C++ has added object-oriented features like classes, objects, inheritance, function overloading, operator overloading, virtual functions, etc. Let us define the learning objective of the session. Initially, we will learn the history of C++. We know that C++ is evolved from C language. Then we will study the differences between C and C++. It is also important to understand the features of C++. We will study the keywords in C++. We will study header file specification. We will get familiar with C++ input and output. We will get familiar with variables and reference variables. We will study about namespaces, get familiar with function prototype and function overloading, study about default arguments, learn about inline functions. Now let us see the differences between C and C++. C is an procedure oriented language, C++ is object oriented language. C is a procedure oriented programming language where more emphasis is laid on the procedures or algorithms rather than data. C++ is object oriented programming language where more emphasis is on the data rather than on procedures or functions. There is no strict type checking in C. Strict type checking is done in C++, so many programs that run well in C compiler will result in errors and warnings under C++ compiler. Concept of default argument is not available in C, whereas the concept of default argument is available in C++. C supports only early binding, in which all the functions related to the function call are resolved at compile time. All individual resolved function calls create an individual .o files which can be later linked together to create a final executable file. C++ supports both early binding and late binding. Late binding is a process of resolving the functions related to the function call during runtime. Here the functions are related to class much after the compilation time. It is also known as dynamic binding. Functions cannot be overloaded in C. Functions can be overloaded in C++. The memory management is done by the built-in functions such as malloc, calloc, realloc and free in C language. A memory management is done by the operators new and delete in C++ language. Declaration of the variables have to be done before the first executable statement within a block, making the declaration of variables more rigid. In C++, declaration of variables can be done at any point in the program wherever necessary, making declaration of variables more flexible compared to the C language. Now let us see the features of C++. The C++ programming language is based on the C language. Although C++ is a descendant of the C language, the two languages are not always compatible. In C++, new data types can be developed that contain functional descriptions, member functions as well as data representations. These new data types are called classes. The job of developing such classes is known as data abstraction. It is possible to work with a combination of classes from established class libraries which help to develop the classes according to the requirement, or derive new classes from existing classes by adding data descriptions and functions. The new classes can contain properties from one or more classes. The classes describe the data type and functions available, but they can hide the implementation details from the client programs. A series of functions can be defined with different argument types that all use the same function name. This is called function overloading. A function can have the same name and argument types in base and derived classes. The meaning of the basic language operators can be redefined so that they can perform operations on user defined classes, in addition to operations on system defined data types such as integer, character and float. Adding properties to operators for new data type is called as operator overloading. The C++ language provides templates and several keywords which are not found in the C language. It also includes features such as try, catch, throw exception handling, stricter type checking and more versatile access to data and functions compared to the C language. Exception handling is done in C++ and strict type checking is also done. Keywords are reserved words whose meaning is already been defined for a particular language. The keywords cannot be used as variable names. The keywords that are available in C++ language can be represented as shown in the table. When a library function is included in the program, it is must to include its header. It is done using #include statement. Example, in C language, to include the header for the IO function, it is must to include the file stdio.h with a statement as #include opening angular bracket stdio.h closing angular bracket. In the above line of code, stdio.h is the name of the file used by the IO functions and the preceding statement causes that the file to be included in the program. When C++ was first invented and for several years after that, C++ used the same style of headers as that of C language, that is, it used header files. The standard C++ supports C style headers for header like iostream.h, fstream.h to maintain backward compatibility. On the other hand, standard C++ creates a new kind of header that is used by standard C++ library. Example, #include angular bracket iostream.h closing angular bracket. The above line of code causes the file iostream.h to be included in the program. The new style headers do not specify file names. Instead, they simply specify standard identifiers that may be mapped to files by the compiler. The new style C++ headers are an abstraction that simply guarantees that the suitable prototypes and definitions required by the C++ library have been declared. Since the new style headers are not file names, they do not have .h extension. They consist of only the header name contained between the angular brackets. For example, angular bracket iostream closing angular bracket. Some of the new versions of the header files are shown in the slide. The main aim of any programming language is to help the user to do certain operations, which include user giving some input to the system, using which processor does some operations and gives back the user the result. Since user cannot speak the hardware language, the high level language like C++ is used as a means of communication by the user, which will be later converted into hardware language during the compilation process to communicate to the hardware. The binary operator greater than sign is also known as extraction operator, which is used to get the data from the object on its left, the standard input stream, and tries to store in the memory location associated with it using the variables towards its right. This operator is a bitwise right shift operator, but it has been overloaded to make it work as an extraction operator. Example, C in extraction operator X. The above statement will wait for the user input. When the user enters the input, the value will be stored inside the variable X. Here the input will be taken from the keyboard. The Cout is used to write the characters to the standard output stream. The operator less than, which is a binary operator, sends the contents of the variable on its right to the object on its left. The operator is also known as the insertion operator. This operator is actually a bitwise left shift operator, but it has been overloaded to make it work as an insertion operator. The advantage of insertion operator is that it does not require any format specifiers like %d, %c, %f, etc. as in C language to represent the data of different data types. Example, Cout, the insertion operator, X equal to insertion operator, the value of X, insertion operator end L. The above statement tries to write the message X equal to and the value of X on the screen or monitor. End L will always go to the next line. A variable is a memory location reserved for use by the program and is referenced by a specific name. A variable contains values that can be modified during the program execution. The values may be data of different types such as integer, float, double, etc. Before using the variable, it should be declared by stating the data type of value that the variable contains. In C, all the variables has a defined at the beginning of scope, that is above all executable statements, whereas in C++, declaration can be done anywhere in the scope, that is variable can be specified where it has to be used. While naming a variable, it must be remembered that the variable name should not be a keyword. A variable name may contain a letter, digit and underscore character, and white spaces are not allowed in the variable name. A syntax to declare a variable is as follows: a data type, variable name and semicolon, or data type, variable name equal to value. Here the initial value will be given to the variable. Now let us see a program to print the value of the variables. We will start with the program. Hash include IOStream, integer main, we will declare the I as of type integer, we will give the value 10 to the variable I, we will display on the screen the value of the variable I. Now we will declare integer j. Now here j variable has declared after the executable statement Cout. We are giving the value 20 to the variable j, we will display the value on the screen using the Cout statement and return 0. Closing bracket for the program. When the above code is compiled and executed, it will produce the following result: I equal to 10, j equal to 20. A reference variable is an implicit pointer. A reference variable is a reference or alias for a previously defined variable. The memory location of the already existing variable is shared by the reference variable. A reference variable should not be initialized to address of an object. The syntax for declaring the reference variable is as follows: data type ampersand reference variable name equal to existing variable, where data type is a type of the data to which the reference variable is pointing to. Ampersand is known as a reference operator. A reference variable is a new variable which is pointing to the already existing variable and act as a reference. Equal to is known as a assignment operator. Existing variable is a previously defined variable which is originally holds the data value. For example, integer I equal to 17, and now we will create a reference variable r, integer ampersand r equal to I. Features of reference variable in C++. A reference variable must be initialized at the time of declaration itself. Once a reference is made to a variable, it cannot be made to refer to any other variable. A variable and its reference are bonded strongly, such that a change in one will necessarily result in a change in other. Like integer, float and double, the reference variable can also be made to reference pointer. The major advantage of reference variable is in passing them as argument to function. These have a greater advantage of over passing the address of a variable to function as pointers. A function can also return by reference. Reference to an array is also allowed in C++. Now, let us see the program to see the usage of reference variables. We will start with the function main. Inside function main, we will declare the variable I of type integer. We will declare the variable d of type double. Now, we will declare the reference r to the integer variable I. Next, we will declare the reference s to the double variable d. Now, we will assign the value 5 to the integer variable I. Now, there are two cout statements where we will display the value of integer I and we will display the value of reference variable. Now, we will assign the value 11.7 to the variable d. Now, we will display the values of variable d and the reference variable s. The output of this particular program will be the value 5, which is for the integer variable I, and its reference variable will be displayed as 5, and the value of variable d and its reference variable will be displayed as 11.7. Namespaces. When a new style header is included in the program, the contents of that header are contained in the standard namespace. A namespace is simply a declarative region. The purpose of a namespace is to restrict the names of identifiers to avoid name conflicts. The elements declared in one namespace are separate from elements declared in another. Initially, the names of the C++ library functions etc. were simply put into the global namespace as they are in C. But with the advent of the new style headers, the contents of these headers were placed in the standard namespace. It is must to include using directive for using the identifiers defined in the namespace scope. The syntax is as follows: using namespace and then the namespace name. For example, using namespace std semicolon. The above statement brings the standard namespace into visibility. That is, it puts standard std into the global namespace. After this statement has been compiled, there is no difference between working with an old style header and a new style one. When a C++ program includes a C header such as stdio.h, its contents are put into a global namespace. This allows a C++ compiler to compile a C subset programs. Now, we will see the program using the namespace. #include iostream. Using namespace standard, here the standard namespace is used. We start with the main function. 3 variables are declared of integer type I, j and sum. We are displaying the message to the user, enter the values for I and j. We are taking the input from the user, C in I, j. We are adding the value of I and j and storing it into sum equal to I, j. Now, we are displaying back the values of I, j and the sum variable, and we are ending with the program. When the above code is compiled and executed, it produces the following result: enter the values of I and j, and if we enter the values as 10 and 20, the result will be displayed as I is 10, j is 20 and sum is 30. Function prototyping is a declaration statement in the calling program which describes the function's interface to the compiler by giving details such as number of arguments passed, data type of arguments, data type of value that function returns. The syntax of function prototyping is as follows: return type, function name, in bracket argument list, where return type is the type of the data the function is expected to return to the calling function. Function name is the name of the function and should be a valid identifier. Argument list contains the type of data, integer, float, double, etc. The function call passes as argument to the function definition. With function prototyping, during a function call, the compiler uses the function prototype to ensure that proper arguments are passed and the return value is handled, and if not, compiler identifies its during compilation type itself and displays the error message because C++ is strict in type checking. An example of function prototyping is as follows: float add in bracket integer x comma float y. The above statement tells the compiler that add is a function which passes two parameters, first one being an integer value and the second one being the float value, and the function add returns the value of floating point type to the calling function. The above example can also be written as float add in bracket integer comma float. The argument name is not required. It just acts as a placeholder for the values. The compiler mainly looks for the type of arguments and it does not matter whether the argument name is specified or no. Now let us see the program to implement the use of function prototype. We will include the file iostream, then there is a function prototype float add integer comma float. So here add is the name of the function. It will accept two parameters, one will be of type integer, second will be of type float, and it will return the float value. Now we will start with the main function. The x has been declared and given the value as 2, y is declared as float and given the value as 3.6, z is again the float value. Z is equal to add xy. Now here we are giving call to a function where x is passed as an argument and y is passed as an argument. Now see out, we are displaying back the values of x, y and z and return 0 from the main function and the main function end. Now let us declare the function add. Now here we are starting with the definition of the function float add integer a comma float b, and we are returning a plus b. Now the function ends. When the above code is compiled and executed, it produces the following result: x is equal to 2, y is equal to 3.6 and z is equal to 5.6. In C++ programming, it is allowed to create two or more functions with the same name, but their parameter declarations should be different. Hence, the functions that share the same name are said to be overloaded and the process is called as function overloading. It is also known as function polymorphism in object-oriented programming. It is possible for the user to create a set of functions with same names, but number and types of parameter list should be different in each function with the help of function overloading. The correct function to be invoked is determined by checking the number and type of arguments, but not on the return type of the function. Hence, function prototype is much necessary and it tries to match a function call to the correct function definition. The compiler tries to implement best matching strategy while performing function overloading on functions, and the strategy is as follows: looks for the exact match of a function prototype with that of a function call statement. In case an exact match is unavailable, it tries to look for nearest exact match. That is, the compiler will perform integral data promotions and then match the call statement with the function prototype. If neither of the case works, then it tries to give an error message. Rules for function overloading. Each overloaded function must differ either by number of its formal parameters, their data types, or sequence of the parameters. The default arguments of the overloaded functions are not considered as a part of the parameter list by C++ compiler. The return type of overloaded functions may or may not be the same. Now let us see a program to implement the use of function overloading. Now here we will include the file IOStream. We are using the namespace. We are having the function to add functions. First one returns an integer value and accepts 2 integer arguments. The second AND function returns the float value and accepts 1 integer and 1 float argument. Now we will start with the main function. Here x1 and x2 are declared as integer, float is f1 is declared as f1. Now we are calling a function add e equal to add x1 and x2, where x1 and x2 both are of type integer. Float f3 is equal to add x2 f1, where x2 is of type integer, f1 is of type float. And now we are having 2 cout statements where we are outputting the values of x1, x2 and e, and second we are outputting the values of x2, f1 and f3, and return 0 where the main function ends. Now we will define 2 functions, integer add where 2 integers are passed as an argument, return I1 plus I2. Now second add function is defined where we are returning I plus f. When the above code is compiled and executed, it produces the following result: x is equal to 2, y is equal to 3.6 and z is equal to 5.6. Default arguments. It is a concept of C++ in which a function assigns the default values for some or all of its formal arguments, which does not have a matching argument in the function call. These default values are called as default arguments. This allows us to call a function without assigning all its arguments. If no value is passed for any of the formal arguments when the function is called, the default value specified in the function prototype is passed to the corresponding formal argument, and if all the arguments are passed when the function is called, then the default value is ignored. Features of default arguments. Default arguments can be assigned to more than one argument. Default arguments can be used to add new parameters to the existing functions. Default arguments can be used to combine similar functions into one. Now let us see the program for default values. Here the volume is a function which is declared with all 3 default arguments: integer equal to 1, integer equal to 2 and integer equal to 3. Now we will start with the main function where some declarations has been made, and now we are calling the function volume with no parameters. Now here when the parameters are not passed, all 3 default arguments will be taken. We are displaying the values of volume. Next we are calling the function volume with 1 parameter length. Okay. Now we are displaying the values on the screen. Now we are calling the volume function with 2 values, length and width. We are displaying some values on the screen. Now we are calling the volume function with all 3 parameters, length, width and height. We are displaying the values and the main function ends. Now we will define the function integer volume, integer L, integer H and integer W as the parameters, and return L into H into W. When the above code is compiled and executed, it will produce the following result. With no argument passed, the result will be 6, where the values, default values has been taken as 1, 2 and 3. Volume with 1 argument passed, it will be 30, where one value was passed, other two will be taken as a default argument. Volume with two arguments passed, the result is 60, where two argument values as taken and one default value was taken. And volume with all argument passed, value is 240, where all three values of parameters has been taken and default arguments has been completely ignored. Inline functions. The objective of using functions in programs is to save a memory space that becomes appreciable when the function is likely to be called many times. If a function is called every time, it takes a lot of extra time in executing a series of instructions for tasks like jumping to a function, saving registers, pushing arguments into the stack and returning to the calling function. When a function is small, a substantial percentage of execution time may be spent in such overheads. One solution given by C is the use of macro preprocessor feature, but the drawback is that they are not really functions, so error checking does not occur during compilation. But C++ overcomes this problem by introducing a new feature called as inline function. It eliminates the cost of calls to small functions. An inline function is a function that is expanded in line when it is invoked. The compiler replaces the function call with the corresponding function code. The functions are made inline when they are small enough to be defined in one or two lines. Now let us see the example of inline function. The syntax will be inline, the function header and the function body. And the example can be a double is a function which is defined as return a into a into a. The above inline function can be invoked by the statement like c equal to cube in bracket 3.0 or d equal to cube into bracket 2.5 plus 1.5. After execution, the value of c and d will be 27 and 64. It is easy to make the function inline. All that is required is to just add the prefix inline to the function definition. All inline functions must be defined before they are called. Some of the situations where inline expansions may not work are for functions returning values, if loop, a switch or a goto exist. For functions not returning values, if a return statement exists. If a functions contain static variables, if inline functions are recursive. Now let us see the use of inline function. Now here the inline function cube has been defined, where the cube function has been called inside the main program. The cube of the number is and the number is passed to the function cube. When the above code is expanded, it will return the value as the cube of the number 1.2 is 1.728. Now let us summarize the contents of the chapter. New data types, that is classes, can be developed that contain functional descriptions as well as data representation. Cin is used to read the characters from the standard input stream. Cout is used to write the characters onto the standard output stream. All C language keywords are valid in C++ and few additional keywords are added in C++. Variables are a sequence of memory locations which are used to store assigned values. A reference variable acts as an alternative name for a previously defined variable. Functions that share the same name are said to be overloaded and the process is called function overloading. Functions prototyping is a mechanism in the calling program which describes the functions interface to the compiler by giving details such as number of arguments passed, data types and so on. Deferred arguments can be used to add new parameters to the existing functions. An inline functions is a function that is expanded inline when it is invoked. The purpose of a namespace is to restrict the names of identifiers to avoid name conflicts.